Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Happy Aloha Friday to you. The week has whipped by and I have my ASU hat on. And sad to say, as I am looking at this, let me show it to you. So here are the March Madness brackets for the Sweet 16. I look over the brackets and, as usual, unfortunately, Arizona State is nowhere to be found. So, nor the U of A, for you U of A fans. It looks like, though, there are, let me count them really quick, 1, 2, 3, 4 of the 12 teams in the Pac-12 are in the Sweet 16. So, the Pac-12, of which ASU is a part, and participates and had a good football season in the Pac-12 in basketball. The Pac-12 is well represented. Anyway, I just wanted to show you that. Some of you got your brackets and all fired up about the Sweet 16. Two of my usually all three of my daughters are involved in it and get fired up about it. I usually don't have time because I'm a teacher. Next year maybe I'll have time. Okay, check this out. You know how I keep telling you March comes in like a lion and is going to go out like a lamb. All right, we've got lion-like weather today. Check that out. Wind and blowing dust advisories today. A front is going through and the wind gusts are going to be as high as 45 miles an hour. No, let's see. Here in Arizona, probably 20 to 35. Over in southwest Imperial County, I think that's in Southern California. It looks like they're going to have higher winds. I would not want to be driving through Palm Springs, California today. You know how they have all those wind turbines, wind fans? Boy, they're going to get the wind right through there. It just funnels right through that gap. Anyway, good news on the snow in the high country, over a foot in many places, unexpected. And another system coming in. They're not saying they'll get much snow out of the next one. The last two, that's what they said, and they got twice as much as they predicted, or even 3 times. So let's pray the same thing. So do it again, Lord. Bring a lot more snow than they expect, so which would be great. So anyway, hey, you've got white sheets. Mr. Phillips helping you out with the white sheets today. If you'll number to 12 on the, Mr. C, you said no pop quiz. I know it's not a pop quiz. So it isn't. You said no test or quiz this week. I know I did. And I'm sticking by my word. Whoop. So, well, wait and see. Just number to 12, though. You've got a number to 12, not an option. And if you'll put name, date, period, upper right-hand corner. So, relax. Breathe in. Breathe out. You'll be okay. No worries. So, anyway, it seems that the flooding in the Nepean River continues to drop in New South Wales state in Australia, where my one daughter Lisa has been sweating, and her whole family, evacuation or not. Looks like not. Praise God. Thank you for that. So quite grateful for that. Well, next week is Good Friday and then Easter weekend. So we won't meet for Happy Aloha Friday next week, but it will be a Happy Aloha Friday too, celebrating Jesus' death in our place. So, and punching our ticket to heaven. So, more on that next week. We have a test next Thursday. So when I suggest that you triple R, then do so. Now, can I show you this? I think I can. Let's see if I can. I'll try to bring this up for you. It should be here. Yeah, here it is. So this was for, I want to show you this. This was the test that many of you are making up and will make up next week. And look what I have here. I've got to do a little bit of maneuvering. Here it is. Okay. Can I make that smaller? Perhaps. Good enough. Okay. So here it is. I'll just show you this. And up it comes. It should come up. So, is it still there? Oh, I know. Sorry. There it is. Okay. All right. This is the 10th of March under homework notes. And see that? All that information? That was the study guide. I had a study guide up. And those of you that are going to make it up can go back, and on the 10th of March under homework notes, RenWeb of course, you can find that study guide and all the topics. I don't tell you the answer to every question, but all the topics. I'm going to do that every week now to the end of school. I already have that up. I shall show you. I have that up already for this week. It's coming. There it is. So let me make it a little bit bigger so it's a little bit more readable. Okay. So this was on Wednesday. Do you see all that? This lists all the topics that we've done this week on the information that has blown your mind, probably like it has mine as well. So anyway, I've got from the standard model of particles down here to the four forces of matter, the Large Hadron Collider, information about all of that. And this will be on the test next week. So, and it will be up in probably next Tuesday's homework notes to get ready for your test. I like you to have 2 nights to look at it. So I'll have it up Tuesday so you can study it Tuesday night and Wednesday night for the Thursday test. Thanks, Mr. C. No worries. So it will be up there. So more to tell, more to show. Man, it's like I need a double period today for you. And I have a video that I want to show you of about gray whales. So I've got to hustle here. So anyway, you've numbered to 12, right, on your white sheet? Number to 12. Number to 12. Number to 12. So so if you didn't make up that March 12th test, you've got to get her done next week by Wednesday. Got to get her done. So it's got to happen. So please get that done. So, okay, I'm looking over this and I think I've got everything else. Now, I want to just go over what I had. Here it is. What I had up in homework notes. I'm just going to go over it with you. I had this first. I had the standard, what's called the standard model, and here's the diagram of it. This is a standard model of elementary particles. It's called the SM, or standard model, and it shows what the basic particles are. It shows what the elementary particles are that everything is made of. Does it include the Higgs boson? Well, look up in the upper right-hand corner. See it there, the Higgs boson. Pink box. So it's got, I'm going to move up a little closer, it's got the major kinds of particles. It's got, if you look, you can see, it's got right over here, quarks. So these are the basic particles now that all matter, everything in the universe is made of. Quarks, leptons, If you put electron, that would be okay. An electron is the kind of lepton. So quarks, leptons, of which an electron is one. And then now we have the Higgs boson. So over on the right side in the purple boxes, those are particles that are involved with the 4 different forces of matter, which I'll go over in just a little bit. So anyway, that's the standard model of elementary particles. There it is. The 3 major kinds of basic particles that everything is made of, that all matter is made of. Remember, matter, anything that has space, takes up space and has mass. Okay? And those particles include quarks, leptons, electrons, and then the Higgs boson. Higgs for the fellow Peter Higgs, the fellow who proposed them back in 1964. They couldn't find the Higgs boson until 2012 in the Hadron Collider on the border of France and Switzerland. So anyway, so there's the standard model. So I wanted you to see that. So I'll make that go bye-bye, and then I want you to see this again. I'm going back and forth. So then I've got information on the Large Hadron Collider, and here's what it says about the Large Hadron Collider. Let's see if I can bring this up. So it's large. It's the LHC. It's large. It's 17 miles around underground. Tunnels and equipment, a massive machine, and it involves hadrons or protons. So hadrons, protons, and then it's a collider. It causes protons to collide. That's why it's called a collider. The Large Hadron Collider. Hadrons are protons. So it smashes protons together at near the speed of light. And then what happens? It studies the debris, what is left over from the collisions, to learn what the smaller particles are that the hadrons or protons are made of. So since we've discovered they're made of quarks, different kinds of quarks, you remember that protons and neutrons, protons have 2 up quarks and 1 down quark, and neutrons, because they only have one, not because, but it's a way to remember it, they have 1 U in their name, so neutrons, 1 up U quark and 2 down quarks. And those quarks causes them, one of the reasons they hold together. So anyway, the Hadron Collider, its purpose is to discover new basic particles. And that's what it's been doing since it was built in, when was it? When did it come online? I'm not quite sure. Maybe around 2006? I'm not exactly sure. Anyway, it costs tens of billions of dollars to build too. So anyway, so the Large Hadron Collider, you know its purpose now. And then the last thing was the Higgs boson, so which you saw a video on. Now, the big deal about the Higgs boson, there's more than 2 big deals, but I'm going to summarize it for you. 2 big deals about the Higgs boson particle. Okay, it was predicted to exist. It was predicted mathematically by Peter Higgs in 1964 and some other guys too that were working on physicist teams. Actually, 2 other teams predicted its existence as well, but they couldn't find it. They couldn't prove it existed. Now they've proved that it exists. So it's a big deal about it. So really 3 big deals. Well, number 1, because it exists, it shows that the Higgs field exists throughout the universe. What is that? It's an invisible energy field. Can we see it? No. Can we feel it? No. We know about its existence now. It was predicted to exist because the Higgs boson exists. So it's an energy field. Okay? I guess you could say maybe like gravity, or also like the magnetic field. So electromagnetic field, like magnets, opposites attracting. We can't see what the energy is that attracts opposite poles of a magnet, but we know it happens. So that's kind of how we know the electromagnetic field exists. Same with the Higgs field that exists everywhere. What's the big deal about the Higgs boson? Shows the Higgs field, energy field exists. So shows that. Number two, the second thing, the Higgs boson is what holds matter together. It's what, in fact, it's what allows matter to exist, atoms to exist. Nothing would exist without it. So we think. So that means our atoms and the atoms of every object wouldn't exist. It's the way Jesus, and then the third important thing, it's the way Jesus has made matter. So, third thing about it. This was Jesus's elegant, divine design for how matter would be made. Have we solved all the mysteries of all this? Oh no, please. In fact, no. There's so many mysteries yet. And it's like God. God is mysterious. We can't know everything about him. So his attributes or qualities are over the top. Well, the things that he makes are over the top, showing that he's over the top. You know, it says in Romans that because of what God made, we can get an idea of what God is like. That's the story here with the Higgs field and the Higgs boson. So complicated. My brain has exploded this week. I have read so many articles about the Higgs boson, and the video that you watched on the Higgs boson, I've watched that 5 times. So, do you have it all down? No, but I understand pretty much what the producers of that video were trying to communicate. So, but anyway, it is so complex, and so is God. So, anyway, those are a number of things that are the big deal about the Higgs boson. So, how are we doing time-wise? Good. Are we going to use our white sheet? Yeah, we are. And then the last thing on your little study guide was the 4 forces. Force is a push or pull. So, a push or an attraction, push or pull, a force. And we now know there are 4 kinds of forces. So there's gravity, right? It's actually the weakest of these 4. There's the weak force that causes fusion to occur on the sun and other stars, we think. So there's again, gravity, the weak force, the electromagnetic force. So there is that, and that involves opposites, the opposites attract principle. And so again, these are the forces. So gravity, the weak force, then there's the electromagnetic force, and then the strong force. And remember, the strong force overcomes the electromagnetic force of protons, which have the same charge. They should repel each other. But the strong force is so strong it overcomes that electromagnetic repulsion and causes an attraction. So it causes matter to hold together. So the strong force. All of this brings God so much glory. It's so elegant. It's so beautiful. So, and it shows fine-tuning in the universe. These mathematical numbers, the strengths of these forces are so perfectly tuned. So, fine-tuning shows a fine-tuner. So anyway, very cool stuff. Okay, so now here's what I'd like to do. I'd like you to close your journals if you have your journal open. I want to ask you really quick 12 questions. So if I can get 12 in. I might not get 12 in. Now, Mr. C, you said you weren't going to give us a test. I'm not. This is an extra credit opportunity. If you get a 9, 90% or 100% on this, turn it in for a grade. I'll give you like a 10 out of 10 or a 9 out of 10 depending on what your score is. Now, if you've got a pretty low score and you want to take an 80 or 85, turn it in. So, and I'll decide whether it will help your average or not, okay? Don't turn it in if it's not going to help you when we're all done. All right, we've got to hurry. So here we go. So I need this right here to help me out. Okay, first I want to ask you about the Large Hadron Collider. The first thing about it is, why is it called large? Just give a brief explanation. Why large? The LHC. Why is it called the Large Hadron Collider? Right fast, so we'll have time to get this in. We may not be able to get in our Divine Design video today. That's okay. Number two. It's called, I'll tell you about the hadron. You can write it down. Why is it called a hadron? Because hadrons are smashed together in the Large Hadron Collider. So hadrons like protons. So give me an example of hadrons. Put down protons. So the Large Hadron Collider. Proton would be an example. Number 2, you're welcome. You're welcome. Okay, number 3. It's called a collider. Why is it called a collider? Why? Explain quickly, bullet fact. And number 4, what's its purpose? What's the purpose of the LHC, the Large Hadron Collider? Then I'll repeat these 4 really quick. What's its purpose? Your journal's closed. You're doing your own work. Mr. Phillip is ensuring that. Number 1, why is the LHC called large? Just give a basic answer. Number 2, hadrons. It involves hadrons, and those are protons, so you've written down proton in number 2. Number 3, why is it called a collider? And number 4, what's its purpose? Okay, 5, 6, 7, and 8. There are 4 basic forces that we know of in the universe. Okay? There are 4. All right? What's the weakest and the most basic that we all know about? That's number 5. The weakest of the 4 forces, and the one we all know about, and that pervades, as far as we can tell, it's God's way of keeping everything in the universe together and space in the universe. It's one of his ways to fine-tune things. So what force is that? Then the next force is, I'll ask you about this. What is the name of the force that overcomes the electromagnetic force that causes like electrical charges to be repelled? So what's the name of the force that overcomes that and holds atomic nuclei together so they don't fly apart? What is that force called? Number 6. Number 7. What is the name of the force that involves fusion on the sun and other stars? That's called the weak force. So I'm giving you number 7. You're welcome. Number 7, weak force. So the weak force actually isn't weak. It's kind of misnamed actually. And then number 8, I've already used it so many times. What do you call the force that involves opposite charges attracting and like charges repelling each other? What is that force called? Number 8. I'll repeat those. If we get a 12 out of 12, will you give us a 12 out of 12? Yeah. If we get an 11 out of 12, will you give us an 11 out of 12? Yeah. Yeah. How much is that? 88%, I think. I think that's right. So, actually, it's a 92. If you get an 11 out of 12, that's a 92. And then I think 83 if you got a 10 out of 12. 5, 6, 83. Yeah, that's right. Okay, 83%. So, anyway, keep it going. Here's 5, 6, and 7. Number 5, the most basic of forces pervades the universe. Space is everything, keeps all objects like galaxies evenly spaced, doesn't let them fly apart, or doesn't let them get too close in most cases. Number 6, what's the force that holds protons together? They shouldn't hold together. Number 7, weak force, I gave it to you. Number 8, opposites attract, like charges repel. What's the name of that force? Number 9. Okay, let's see what else I want to ask. That. 9 and 10. Give me 2 of the basic particles. 2 of the basic particles. How many are we searching for? There's 4, so give me 2 out of the 4. 1 and 9, 1 and 10. Kinds of particles that can't be divided anymore. They actually are the undividable ones. So 1 and 9, 1 and 10. Hey, I didn't mention these, so I'll give it to you. In 9 and 10, you can use one of these. Actually, I'll do 9, 10, and 11. And here's 11. I'm giving it to you. One of the 4 particles stream off the sun. They're very tiny. They're traveling at the speed of light. And 100 trillion of them pass through our body every second. So they're called neutrinos. So Neutrinos, number 11. You're welcome. So I've given you 3, right? And then in number 12, I want you to put one of the big deals about the Higgs boson particle. What's one of the big deals about it? Just one, number 12. Go. One of the big deals about the Higgs boson particle. There's a bunch of things that are a big deal about it. This is a big deal. There's about 4 big deals, actually. I might have named all 4. So one big deal about the Higgs boson. Finish up really quick. Now, because I'm offering you extra credit, I can't give you unlimited time on this. Mr. Chambers, I haven't finished. Sorry about that. It's part of the deal of you either kind of know it or you don't. If you know it, then you're going to end up getting the bonus grade. And if you're struggling, this is a nice little review for next week. So, anyway, it's all good. So, but don't be on my case. If you're going, you didn't give us enough time. Yes, I did. I did. For those of you who have really got it down and you've been reviewing, you were supposed to review this last night. So you need to be rewarded, those of you that have been reviewing and paying attention. How about if I was been picking my nose this week and I really haven't been writing down bullet facts much? You don't deserve to be rewarded. And, what can I say? So rewards come with those who earn them. All right. Here's what I'd like you to do. I'd like you quickly to take out a different color writing tool. If you wrote with ink, take out a pencil. If you wrote with pencil, take out an ink pen or a red pen. Different Different writing tool. Quick, quick. Not looking around, getting answers from anybody. Quick, quick. Hurry, scurry. All right, here are your answers. So just the one writing thing out, that's it. Everything else is put away. Be honest. Don't even think about turning it in if you weren't honest. Okay. I'd turn it in if you got a 10 or 11 or 12. Okay. It's a number right out of 12. Why is the LHC called Large Hadron Collider? Because it's huge. It's miles around underground. It's a massive machine underground that's miles around. 17 miles almost, to be exact. Number 2, why is it called Hadron? Because it involves protons. And I gave that to you, number 2, protons. Why is it called a collider? Because it slams protons together. It makes them collide. And that's number 3. It slams protons together. And you've got to mention protons in number 3. If you just said it's an atom smasher, I'll give you half in number 3. What is its purpose? You've got to have more than just slams atoms together. It slams atoms together, here's the major purpose, to discover new particles that the bigger particles are made of, that the protons are made of. Smashes them together, they break apart, and then they look for new particles. That's the purpose. Number 5, what's the force that pervades the universe and kind of holds everything in place? Gravity. Number 5, gravity. That's it. You got to have gravity. Number 6, a strong force or the strong nuclear force. Strong force, number 6. I gave you 7, the weak force, and that is responsible for, and it's perfect, it's got the perfect amount of force to allow fusion to occur, but at just the right amount and but still the stars stay together. So the weak force, number 7. Number 8, you had to come up with it, the electromagnetic force. If you just had magnetic, half, 1/2. Electromagnetic force for number 8. If you had just electro, half. If you had magnetic, half. Electromagnetic, whole point. All right, 9, 10, and 11. 3 of the 4 particles. Quarks. Protons are made of quarks. Leptons, or you could put electrons. Now you can't put leptons and electrons. So quarks, leptons, or substitute electrons for leptons. Neutrinos I gave you, and then the other one is the Higgs boson. So you could have, in those 3, 9, 10, and 11, you could use those 4 answers. They were like in your answer bank. Quarks, leptons, aka electrons, neutrinos that pass through everything. They pass through the Earth, they're traveling so fast. And then the Higgs boson, quarks, leptons, aka electrons, neutrinos, and Higgs boson particle. Okay, there you have it. So, and so 9, 10, and 11, I'm sorry, the big deals. Here are the big deals. The big deal is, first, it lets us know that the Higgs field actually exists. So there's one big deal. Number 2, it shows God designed the Higgs boson and matter. Or the other big deal is it's what holds matter together or holds atoms together. So it reveals God, it reveals the Higgs field and the Higgs boson, and it reveals how awesome God is. And you could say it reveals how complex how complex atoms are, which tells us how complex God is by the stuff that He made. So put a question mark by it if you wonder about the big deal. Put your score at the top that you think you got, number right over 12. Make sure your name's on it. If you hand it in without a name, I'm probably not going to be able to give you the score, because I'm not going to look real hard to find out who you are, because it's a pain. Upper right hand corner, name, date, period. If you're passing, I pass it in if you had a 9. I pass it. I'm sorry. If you had a 10, 11, or 12. Get it together, Mr. C. 10, 11, or 12. Okay? And that's going to take care of the period. I'm going to turn it over to Mr. Phillip. You have yourself a great weekend, and I'll see you back on Monday. Mr. Phillip, thanks.